decide that, that digital write function is really just too gosh darn slow, you can just put in port B or equals 1 and dump it in the middle of your code and it'll work fine. So we want you to understand how the things in Arduino are working, because that will let you figure out what to do when their functions either don't work or don't do what you want, or you find sample code online and you don't understand what it's doing. So going forward, you may come across a gadget for which you want to use an Arduino, and by all means you should. If it's doing what you want and it's doing it in the best way for what you want. So now that we've gone over kind of what Arduinos are and all that stuff, let's talk about how you actually use them in your gadgets. So the first way to use an Arduino is what I was explaining before. You can literally just go onto some website and buy a whole bunch of Arduino junk and strap it together, and what you end up with is usually a stack like this. Like, this is pretty close to what our robot that we designed at the beginning of class would be working off of. You have your motor controller thing up there, you have some IMU module in the middle, you have a communications module, you have an Arduino baseboard on the bottom that you can program. So it's pretty large. It's not getting any smaller. There's no real way to do anything besides those exact functions with it. But if I didn't know if this was going to work, if I just wanted to see if maybe I could make a robot that would be able to bounce off of walls, and I didn't really care about making any more than one of it, well, then this might be a good way to start out. So if you're not too concerned about space, you're just interested in figuring out functionality, interested in figuring out sort of the right idea for your gadget in the first place, and you don't mind the extra cost, just getting Arduino models and putting them together is a really good way to go. And it's really common on hobby sites for them to recommend that you do this for various things. The other thing to keep in mind is that the shields have to sort of do what you want. There's a little bit of a caveat in that these shields all just plug together on the same pins. And there's nothing really saying that they can't use the same pins or that they have to be compatible with each other. And so when you plug shields together, you have to be a little bit careful that they're not all using the same serial port or all using the same SPI lines, because then you'll just be screwed. And there's no real way for you to get around that aside from actually physically cutting and mucking around the ports. So it's sort of if you're lucky enough that your gadget is in the space of gadgets that Arduino was expecting you to make, then you're sort of set. You do this, you spend a little extra money, you get your thing in a week, you plug it together, you're good to go. Now, okay, that may or may not happen. If it does, great. But there's another alternative, which is you can buy one of the smaller Arduinos, or you can buy a big Arduino too, and you can plug it into a custom design board. Essentially, you can make your own shields. There's nothing magical about them. Essentially, they're just pinning out the same pins as the microcontroller on your board. So you can take the open source design from Arduino, you can look at where the headers are laid out, you make an eagle part for that, and actually just use that as a part in your own layout to plug against. And then you don't have to worry about some of the stuff like having a bootloader or initially programming it or getting the USB ports to work properly or things like that. So you can avoid a little bit of trouble when you're first making a gadget, or if you want to make a simple gadget that you can use an existing microcontroller on. And this is a really good option for you kind of know what you want, or you have a very specific set of hardware that you want to interface to, or a specific form factor, and you're willing to sacrifice a little bit of space and a little bit of functionality in order for you to just plug this thing in and have it be able to be programmed. So this sort of guarantees that that first step of you plugging it in and having something that can sort of talk to you over serial and stuff like that is all sort of guaranteed. You don't have to worry about it. And this is pretty easy to do, and this is actually largely what I do. I mean, these guys sort of poke at me for it, but I do design a lot of parts where I just will stick an Arduino in it just so I don't have to deal with the hassle of actually doing initial programming and getting stuff up and running. I can kind of know if I plug it in and it powers up, I'm going to be able to program it, I'm going to be able to mess around with it. Now, of course, the more complex option is that you can make your own Arduino board. There's nothing special about that either. In fact, if you look at the Eagle files that they're providing, they're exactly the same as the Eagle files that you're generating. In some cases, the Eagle files that you generate might be better in certain ways. So if you don't mind the fact that their firmware is going to kind of restrict what you can do with the different pins, you can actually take their entire schematic and portions of their layout and copy it into your own Eagle file. And basically, once you initially flash firmware onto this device, it will function exactly the same as an Arduino. You can use it in the Arduino IDE. You can basically treat it like an Arduino. All of the same code will roughly work if you use the same processor. You still have to sort of be wary of how they've assigned pins. So for example, if they've defined a pin as an analog pin, then by God, that thing is never going to read digital properly, because their firmware libraries will simply just overwrite everything that you were doing. But this is the most flexible option, and this gives you a lot of the benefit of both worlds. You can still use their IDE. It's really easy to use libraries and sample code, but you still get to pick exactly the right form factor and function and pricing for everything going on your board. You know, if you don't like an Atmega 328, it's too small, you know, you can put a bigger chip on it, you can put a slightly smaller chip. It doesn't have to be the same series. But this is a pretty good option. And this is actually what we will be allowing in Gadget 2. So as to how Arduinos relate to Gadget 2, basically, since you're going to be putting an Atmel microprocessor on there anyway, you can totally copy one of the Arduino schematics to get an Arduino compatible microprocessor to be on it. And we'll be helping in a limited fashion in the sense that we'll make sure your board powers on and that the general programming works out, but we won't necessarily help you with any Arduino specific related stuff. And we're certainly not going to debug it if you stick their gigantic 84 megahertz Cortex on there and it doesn't work. Because, I mean, geez, there's like 100 million things that could have gone wrong there. But basically, if you want to use the IDE and play around with stuff, you have an option to, again, to sort of, your mileage may vary.
Yeah, so our theory is we don't want you just making a part and building a shield, but you can build an entire Arduino, which sounds scary, but you can literally take the Arduino and you already have an entire Arduino just by downloading the reference design. But what we expect is that you'd say, well, I'm going to actually make it so that there's an accelerometer just directly on my Arduino. Maybe there's a Wi-Fi module or whatever else you're interested in. Like you just,
or you want a different form factor than the standard everything.
You can have a circular Arduino. And people say, where did you get that? You can say, well, I made it. And you know, and then when you get to the programming, you all have the ISP, and all you'll do is you'll use it once to put on the Arduino bootloader, and then you can use your Arduino infrastructure from then on out, which is why it's very handy to have an ISP. And if you only ever do Arduino stuff, and you say, oh, my Arduino stopped going, I'm sad. You know, that's because you have no ISP, no way to like fix the bootloader or do anything about it. So that's what we're sort of thinking with the Arduino. So definitely, yes, take the open source reference designs. There are 87 million Arduinos now, so pick and choose whichever one you want. Do you want USB? Do you want the tiny chip? Do you want the big chip? And you know, go wild. And we expect you'll add at least a little bit of extra functionality to it.
Yep. If you're making all that, you might as well dump on the 2 or 3 other things that you were going to make on your gadget.
You're not just going to take the open source design, change the text on it to your name, and say, great, I'm done. You know, this is the easiest Gadget 2 ever. That's not going to fly. But you know, there's no reason for us to not let you guys use Arduinos. In the past, people grumbled furiously or less furiously that we're sort of hamstringing you with these like regular processors and not letting you use the Arduino programming environment. And in theory, you might even be able to make something that doesn't look anything like an Arduino and still use their environment. But that's sort of beyond the scope of what we can help you with.
I believe the modern IDE actually supports Everest 1.2 these days.
Okay.
It's getting pretty full featured. So the basic moral of the Arduino story is that they're out there and they do a lot of the same stuff as what you guys have been doing. So think of them as a tool in your arsenal to save you time and money. In situations where you're prototyping, in situations where you don't really care about the form factor and you just want to get stuff up and running, and Arduino is a really good option to get you a huge step of the way there without you having to do much work at all. But don't use them just for Arduino's sake. Don't use them just because like everyone's using Arduino and it's totally the right way to do it, that I'll make a stack like this tall of shields and none of them work with each other and they cost me like $800, which people do. If you Google Arduino shields, you can get people who are doing really, really dumb stuff like making Beowulf clusters of Arduinos. You know, it's like, oh yeah, I put all of these together and I have the total computing capacity of my calculator. Okay, great. It cost you $10,000, and why did you do that? But, you know, Arduinos are useful in the right ways. And so, hopefully, at the end of the day, when you're going out and making gadgets after this class, which hopefully some portion of you will do, you can look at a gadget and be like, you know, I see how I would make this gadget. I can also see that it would probably save me a bit of time and money to use part of an Arduino or an Arduino module or make a shield myself and plug an Arduino into it. And this is overall going to save me time and money in the long run of how complex my design is and what I need to put into it.
And again, this class, I don't know why, but we sort of skipped the prototyping phase of our design. Like we just sort of say, okay, nobody's breadboarding any of their circuits. We're just going to go straight into designing a schematic and making a custom circuit board. But Arduino is a great way to prototype slightly more complex stuff. But again, you know, you're building a gadget. You say, okay, we've tested it on the bench. We have the Arduino, you know, skyscraper here that does everything we want. But now we're going to make like 300 of these for some project, and like they have to fit in these little boxes. You know, that's where this stuff comes back in when you say, wait, are we really going to try to just fit all this stuff in here, or am I going to just grab all these open source schematics, copy and paste all the circuits I want into one schematic, lay it out to fit our thing, and you know, you can still use the Arduino programming language, you can still use all of the Arduino reference designs. You've just made the thing, you know, an actual useful gadget that's going to be cheap to make in large quantities. You sort of optimized all the little corners of the design. Now that you know what it has to do.
So anyway, it's a short lecture on Arduinos. I'm going to spend the rest of the lecture and do a live session of copying that schematic over, fiddling with it a bit, and messing with the coding. We can show some examples of specific digital communication stuff.
So is anybody excited about using an Arduino for Gadget 2? Is anyone going to do it anyway, even if they're not very excited? Wow. So it's an option. And you know, if you hate the programming stuff and you want to use the pretty blue IDE instead of the crufty WinnieVR stuff, that's pretty cool. I mean, I think programmers Notepad has the colors too. And if you go up to the programming, make program, it kind of does the pretty sketch, compile, and verify. We're ignoring the red stuff at the bottom, just like the other one. Yep.
Sorry, so just to clarify, so we're allowed to use actual Arduino boards, or we design your own Arduino?
You can go get a reference schematic from your favorite Arduino.
Okay.
And if you don't mess with the schematic and lay out too much, what you're going to do is then add in whatever else you'd like. So what we're saying is you can make an Arduino, but not an Arduino shield, if that makes sense to you.
Okay.
So you can't go and buy an Arduino board and then just make a board that sits on top of it. That's
Okay.
not.
Okay.
But what we can tell you is that if you take their reference design for a standard
So
Arduino,
it's still printing our own?
yeah, presumably you'd add some extra stuff. So like just put your LEDs right on the board, put your accelerometer on, and then as long as you didn't poke at too many of those programming lines, the weird circuits they add that you don't quite understand, if you don't mess with those, we can put on their bootloader using the ISP, and then like it's an Arduino. It just happens to have like special things on pin 15. And like your LED is like soldered onto pin 15.
Wait, so then it also makes it much.
So if you like the Arduino programming and you want nothing to do with our devilish port B or equals blah, and you never want to see that again, this is your way out.
Okay.
Yeah.
You only get a technical zero on your home,
Absolutely. And again, it's all about, and we're going to talk about that. We're going to talk about specifically what kind of libraries, reference libraries you can use for the ATmega and XMegas. For Gadget 2, you don't have to sort of cobble everything together from scratch if you don't want to. And again, like the high level, like if Pross goes to his loop, now your homework, we sort of made you guys all just stay in the muck, you know, with all the low-level function implementations. But if you went to the main functions, they looked kind of similar. Tom did this init function, which really just held all the other inits that you guys were writing. And then he had a void main, blah, blah, blah. But then it had a while one loop, which suspiciously, you know, this one's called a loop, never exits, keeps running over and over again. Like, it's doing the exact same thing that Tom's thing is doing. And then, you know, you can write this exact same code. Like, there's nothing saying that you can't have if serial available. I always use, you know, if, you know, byte read doesn't equal -1. You know, it's the same sort of thing. Read the byte, switch the byte. You know, there's nothing here. None of this is very Arduino specific. You would need to implement serial.write. In the AVR GCC world, there's this wonderful thing called printf. You may have heard of it if you've done any programming on a computer, where I would simply just say printf banana. If you have 7 serial ports, I would do fprintf, comma, serial, ampersand serial1, comma, banana. And it works the same way.
And internally, that's what they're doing. It's just here they've cleaned it up. They give you an object called serial and serial 1 and serial 2.
Yeah. So ultimately, you can make your main code look as clean as you like. There's no reason to make it, you know, if you don't like how Tom wrote his code, you can, you know, write it in a more programmer-friendly way. There's limited C++ support. You can actually do, you know, serial.write if you really want, instead of just write serial or printf. But, you know, it all kind of works the same. But yeah, so if you want to use Arduino, there's no reason not to. And if you want to make it look like this, there's no reason not to.
So in Arduino,
Yeah, so in the other Arduino,
now,
meanwhile in Arduino,
well, helpfully, the Mac puts the title bar on this screen and the rest of it on that screen,
Yes.
so this is going to take a little bit of looking back and forth.
so we're going to find the schematic.
Yeah, I can get this back. Okay. Oh no, that's not the right one. There. Okay, so if we were for Gadget 2 using this Arduino, we could probably just.
So what are those 2 pins right here?
Oh yeah, those are on the FTDI chip.
Oh, that's the FTDI, I'm sorry.
Yes. This is the. Uh,
2 or 3?
yes. Okay, this is the Mega with all of its lovely pins, which you could simply pin out to things other than a connector. So if you wanted to put your potentiometer or something there, then you could do that. Now, the caveat is that it's going conforming. These pins are normally programmable, but Arduino's firmware just assigns them random. So for example, these 6 pins up here are just analog. They will never work for digital. And if you put anything on them that is not something that you want to read as an analog input, then you can't do anything with it.
One thing I'll point out, Arduino, they're Italian. They use European electrical standards, which is why the capacitors look different and why the resistors look different. LEDs kind of look the same, crystals look the same. Stylistically, you can use whatever you're sort of stuck with. Please don't mix and match. It'll just drive us crazy.
You'll notice it on your schematic when you have to.
So if your resistors look like this, don't try to find the package, just use the copy command and you can have however many extra resistors you need.
Or feel free to replace their resistors. There's nothing special about their resistors. They're just resistors.
Or you may find that they're using the giant sort of Duplo dip version of all the microcontrollers, generally because they're cheaper to have someone assemble by hand. But if you want to have a much smaller board and you don't want to have Tom and I cry that you guys are using a through-hole dip, you know, where did we lead you wrong? You know, you can replace the package of this with a much smaller one. And you may find that you get bonus pins. You get 2 free analog pins that your Arduino knows nothing about. You could hook up to your secret sensors, and then in your code, you can modify these sensors and not have to worry about their Arduino overwriting because it doesn't know they exist. And that may be even more the case on the larger Arduinos where they kind of said, well, we have the standard pin headers that we put everywhere, but we've got like 10 extra pins. Let's just leave them blank and not use them, which is what I think they must do.
Yep, that's basically what they do. The other thing that they do is just aggressively hard code the functionality of pins. So they'll just be like, these are the PWM pins, like all 20 of them. You know, it's just, well, now you can't use them for anything else. They're just for that. Which is fine when you can't actually get those pins physically off the board. Just keep in mind, Arduino is really pushing everything onto these connectors. So anything they can't fit into their connectors is effectively wasted on their ports. So they'll just randomly assign stuff so they don't have stuff that isn't getting routed to connectors somewhere. So we can take a look at the more complicated Cortex, but I don't think it's really basically just this one.
Yeah, some setup stuff. So if you're copying one, feel free to like add whatever you like on the pins. I'd recommend not monkeying with like their infrastructure stuff. So like the crystal, you want to leave that alone. The reference, the capacitor on ABCC, things like that. You know, if you can ask us, and we'll tell you, what it's doing. And we can sort of give you suggestions. Leave the port regulator alone. Unless you want to use a nicer regulator, use a nicer power switch. Do they even have power switches?
No, they have the auto power switch for internal perception.
Yeah. So if you wanted to like make an advanced Arduino, you could add the power switch, which is this complicated thing that lets you turn it on and off an electronic device. And somehow it doesn't make it into any of these sort of low-level, used by millions of people or thousands of people. And they don't have power switches. So you can bring it to the masses.
Yep, so that's Arduinos. I'm gonna pass this around so you can take a look at it. This is an example of a nano Arduino and a shield together, which just pins it out. There's actually two components. So this is a small Arduino. This is actually the Arduino part. This is just a carrier board. This is a shield for this. So I'll pass this around so you guys can check it out. I think it still has the serial code, so if any of you have a serial port and know how to quickly get it up and running, you can play with it and have it do its ABCD Cape Dragon thing. But yeah, so basically that's the long and short of it. Arduino's website is helpfully Italian, arduino.cc. And if you Google Arduino, you will simply find them because they're everywhere.
Anyone not heard of Arduino before coming to this class?
All right.
Yeah, we didn't think so.
Yep. Has anyone not used Arduino? Okay. So now you have some idea what to expect. You can see that if you get to, they have a lot of reference material on their code, but this is mostly C++ and C code, but they're just like if statements. If you don't know how to use a switch case statement, go to their site and they'll tell you, which is kind of nice. I think one other thing, which I can find in here, Arduino does actually have a statement about using, here we go. So you want to make an Arduino. Basically what they say here is we do not care at all if you guys make your own Arduino. So just to clarify, we're not stepping on anyone's toes here. Arduino is totally cool with you guys making your own spin-off, rip-off Arduinos. And even with selling them, as long as you, if you're going to sell them, there's some licenses associated with it, which are basically just, you can't brand it as Arduino, you can't, steal their design and try and resell it. But you can sell boards, which are basically Arduinos, they don't care. There's a lot of helpful advice they have on if you want to license stuff with them, which I don't think you all want to do. Okay, so that's the end of my formal lecture, as I mentioned this. Cool. Well, short lecture, I can answer questions about Arduinos. I've used them for many years. Or I think you're using them or using parts of them in your gadgets. I would be happy to answer questions about that now or after class, which are kind of the same thing since they were
All right, any questions on, questions on Arduino? Questions on Gadget 2 in general? On Wednesday, we're going to talk more about the crufty monkey versions of how to stay with 18 megas and X megas, and how to do like high-speed stuff for those of you who want speed and not ease of use. Then the last thing is, anyone have any big problems with Gadget 1, getting it ordered, getting it put together, turning it on, and having it stay on and not blow up anything? All right.
Actually, just a question about adding the housing design to a website.
Yes.
You're supposed to create a different section on your website, or
No, just edit the text.
Edit the text.
Basically just, you know,
Like
try to
clear
make,
the bottom
make
of
it
your
clear.
Yeah, so just, advanced Drupal-based HTML editing,
Okay.
new section maybe. Please make them readable. If it's just a block of text, that makes us sad to read, and then that kind of affects what we think.
When you edit stuff, do you get a little editor or? just-
yeah, there's a little icons.
No, not just the box, but like
If you're having any trouble with the website,
fonts and stuff.
please do your best. You can also email us a copy at CMU Gadgetry, but sort of use that as a last resort.